Turned on the mic? Yep. Okay. Hello? Don't know. Can't tell. Oops. I'm not sure I'm working. So, thank you.
Okay, welcome everyone. I'm Yatza Frank with Building Energy Exchange. Thank you all for coming this evening. I'm sure more folks are going to trickle in as well as it's an end of the day program. Everybody's scrambling to get out of the office. Really looking forward to these presentations. This is a joint program with New York Passive House. So Andreas is going to take the mic in a moment and sort of prep you all for the rest of the evening. But we have three really solid architecture firms doing really interesting work. The kind of complexity and diversity of the projects that we're going to look at, in some cases the height of the projects we're going to look at are very exciting to a lot of us in terms of seeing Passive House kind of moving into our community in a much broader way every month, it seems. We've been doing a lot of work around Passive House, although that's not our exclusive interest here at Building Energy Exchange. But a couple of things I want to note. We developed a 1-hour primer on Passive House, very visual, very non-technical for folks that are interested but kind of aren't prepared for a full-day seminar or certainly not the kind of week-long certified Passive House training. It's kind of an intro. We've put together a group of about 15 really excellent instructors that deliver this for free, so they'll bring it to your office if your office has interest in this. So reach out to us if you want to do that. Sean Torbert, who's here, is one of our instructors, but it's an excellent group of folks. And we just published a report on retrofitting to Passive House standard. It's a report that looks at an actual existing occupied multifamily building in Brooklyn and looks at all the strategies that would be required to bring it up to the EnerPHit standard. We spent quite a bit of time on it. It's about 50 pages, so take a deep breath if you dive in, but this is available on our website as well, so check that out. We have a number of things coming up on the calendar, including certified Passive House training by NAFAN, which starts, is that November 12th? Is that right, Sharon? Yeah. So here in the space, so excited about that as well. I'm going to hand it over to Andreas. He's going to kind of prep you. After the presentations, Sean Torbert from Rockwool is going to kind of lead questions with our panel, and then there'll be a time for audience questions as well. So, Andreas, take it away.
Thank you so much. So my name is Andreas Bensing. I'm a part of New York Passive House, partnering with BAX at today's event. We thought it would be interesting to have not just one presentation, but to present 3 offices doing large Passive House buildings in the city, and demonstrating how Passive House quality changes the practice of architecture and hopefully the building industry in general. We have a book which we did for our Passive House conference in June, so you can pick up an example outside. It's free for you. Next slide, please. So it's my pleasure to introduce to you John Wolfling, principal at Duttner Architects, Mark Ginsberg, who is principal at Curtis Ginsberg Architects, and Ryan Lobello, who's associate at Handel Architects. Next slide, please. So the updated IPCC report, I think everyone saw it, pushed us a little bit harder, I think, and envisions a CO2 emission reduction of 54% by 2030, and actually net zero at around 2050. So that's a big challenge we have to tackle, and a lot will come from buildings. Next slide, please. So currently we operate under the one city built to last assumption called the Plan 80 by 50, which envisions an 80% reduction of greenhouse gas emissions, so it's not comparable with the IPCC report, by 2050. And 60% will come from building, at least in this scenario. New York City, of course, our greenhouse gas emissions, the biggest portion, 2/3, come from building itself. Next, please.
Should I?
Yeah, so the building code is somewhat a slow-moving animal, of course, as we know. We have to speed up that process. But we did make progress, 50% better than 2075 currently. I think that's progress, but obviously is not good enough. And the city will propose a stretch code, which will be an overlay onto the residential, the state energy code. And it will be interesting once it comes out. It will have some interesting passive house section in it, and hopefully the city will adopt it. Next.
Did you want to say something on this? No. Okay.
In general, commercial buildings use about 200 EUIs, so the energy use intensity. Commercial buildings currently are in between 130 and 150, so that's the overall source energy a building uses per square foot and per year. And the plan, the 80 by 50 plan, envisions to come down to 84 EUI, so as an average for the entire city. Of course, since a lot of buildings will be around for a long time, we will have to come further down than 84. Next slide, please. So the passive house concept envisions an EUI. It's not 100% comparable, but it's close enough for our purpose. Envisions an EUI, or an energy demand, of 38, so that's a very low energy demand overall. And it also requires a heating demand of 4.75 kilobtu per square foot. And it has also as a criterion a cooling demand, which is similar to the heating demand, plus an adjusted allowance for cooling dehumidification loads. Of course, it also requires a very airtight building, so it's an ACH 50, so under 50 Pascal pressure of 0.6. That's very low, but as we will see, very much achievable by larger buildings especially. And you have to use ERV or heat recovery ventilation. You don't have to, but of course, it's part of the system. Next slide, please. So we prepared a little slide with the 5 principles. I would like to see who knows passive house already. Then we can skip it. Who feels like you would like to repeat the 5 principles quickly? Always helps. 2 people, that's good, that's great. So the core principle is really making a higher quality building shell. That's in one sentence. It requires you a climate-specific insulation layer, right? It requires you to have that very airtight building shell. It has to be continuous to avoid damage in your building because of moisture and air movement through your wall. It requires you to use thermal bridge-free construction, very important in order to keep surface temperatures inside your building at a high level to avoid some comfort problems and condensation. Uses a well-designed ventilation system. Of course, we want to bring fresh air into the building, but with heat recovery to improve indoor air quality. And very sophisticated window design, which we will talk about as well. Next, please. We are very excited to see a real growth in passive house buildings in the city, especially it started in Brooklyn, but now we are moving into Manhattan. So we're really moving into the larger buildings to the passive house standard, and it's very exciting to see those projects today. With that said, I would like to hand it over to the experts. Okay. Thank you so much.
Okay, so this is a little less washed out than the last slide. Sorry about that. But you can see that our 3 firms are experienced in New York City, and even Ryan's office has some projects a little north, which he'll talk about in a little bit. But what I think is important about this is that Passive House is prescriptive. It doesn't tell you, it tells you what to achieve, it doesn't tell you how to achieve it. So what we really want to show you to you tonight is the various strategies that we've all used. We have similar size projects, but their envelopes are different, their methods for energy recovery are different, their methods for insulation are different. So we think that this is a good primer for everyone to kind of see what's going on and how you achieve multi-family housing with Passive House. So as I said, similar size projects. What's also interesting as we go through this, keep an eye out for which system we're using. There's PHIUS and PHI. We're not going to get into the details about how those two systems are different tonight, but I think it's interesting that you can do either of those programs in New York City. We're also on my firm's projects, we're using exclusively VRF and ERV with slight variations of those two systems. Different superstructures and also different envelopes, which we're going to get into in a little bit more detail in a bit.
So on our projects, and there's actually a slight inaccuracy, Beach Green Dune Phase 1 was finished a year ago, and I'll talk about that near the end, about the energy consumption. Phase 2 is in construction. Morris 2 is about a week away from a TCO. We hope it's passed its blower door test, which is for important. Melrose North is in design. Third Avenue got a TCO a month ago and also passed its blower door test, so it isn't fully certified yet, but we expect it to be. And both Cyrus House and Mapes are in design. So we've done a number, and what's interesting is having done a number with the same client, after we've designed the first one and they're building it, they want to change some of the others. So I'll talk about why we've made some of the changes.
So you guys are probably familiar with this one. That's the Cornell Tech, the house. When it was finished, it was the world's tallest passive house. Not the largest. There's an office building in Vienna that was a little bit larger. It's since been surpassed by a taller and larger residential building in Bilbao. Beautiful building. And so that was completed a year ago. Is a dorm, but it's an R2 building. So it's for graduate students. We treat it like a normal New York City apartment building. It's a prefabricated metal panel system. Just wanted to note that all this passive house, we filled out some paperwork, and we got lead project of the year 2017. Just happened. And then Sendero Verde's project I'm currently working on right now. It's 3 buildings, a tower, and then 2 low-rise with a pretty extensive community facility at the base. There's a school, there's some medical offices, that type of thing, and then this kind of public park in the middle. And that's brick on the tower and the base, and then EFIS at the low-rise residential buildings. And then this is a project we're currently working on, just broke ground last week. It's 155 Winthrop, and this is just kind of to show that, passive house, you don't have to do the entire building as passive house. It's a 1.8 million square feet, 53-floor building, but only the commercial office program, which is that portion of the building, is being certified passive house. It's still pretty big, but you don't have to do the whole thing. So if there's program parameters, you got residential condo buildings that don't quite meet passive house criteria, it's okay. You can split your building up. So we're going to start first. We're going to talk about the envelope and why is passive house so well suited to high-rise residential. And it's because of this low surface to volume ratio. When you think about a single-family home, you have 6 different surfaces that you have to insulate and make airtight. And this is one floor plate of the Cornell Tech building. And you can see like half of this building is studios. And this is a typical studio. It's just one surface that you have to worry about the environment. So it's really it kind of takes care of a lot of the problems of a single family when you blow it up to this scale.
So I'm going to talk a little bit about 425 Grand Concourse, which is a project in the Bronx. It's an all-affordable building. 277 units of housing. Ryan touched on something that's really important about passive house and multifamily. Another component of that is in these multifamily buildings, there is so much occupancy density. And one of the main benefits, or one of the things that makes passive house possible, is that you're using all those internal heat gains from lighting, from occupants, from appliances. So when you get more people jammed into a building, you get that higher occupancy density, the building can really take advantage of that. So there's all of these projects that you're going to see are really utilizing that as an inherent sustainability strategy. So 425 Grand Concourse. We started with an envelope approach very similar to what Ryan's office did at the Cornell Tech building. And we thought it was great. A mega panel system, it's going to have high quality assurance. But we moved away from that, and I'm going to get into that in a little bit. We moved away from it and we're doing a stick-built system, or a field-built system that has a mason involved, it's got a window installer involved, it's got a sealant contractor, there's an air barrier contractor. There's a lot of hands on this envelope. And one of our real concerns about it is with all these hands, you're going to have people pointing their fingers. And so the quality assurance for the air barrier, Andreas mentioned how important the air barrier is. If you don't get the air barrier continuity on a passive house project, you ain't passive house. So it's really important that you approach your envelope from this, a high due diligence. So I'm going to walk you through how the sequence is going to work and why we feel confident that it's going to work. So start with the superstructure. It's a cast-in-place concrete building. We're going to erect the backup wall, which is a CMU backup wall, very robust wall that's not going to have a lot of movement associated with it. After that, we have a movement joint incorporated in here that's going to have a little wrinkle. There's going to be movement allowed for at the top of this precast lintel. The air barrier will go on and will flash all of our openings, and then the window can go in. And the reason why this is really important is a construction sequencing issue, is that once these windows go in, all of the interior finishes can start in advance of the envelope being completed and all buttoned up. With a mega panel approach, you've got to get the mega panels on site, get them all erected, and then you can start your interior finishes. But we're able to start it a lot earlier here and shorten the construction sequencing. So that's one of the main advantages of this approach. But there are drawbacks, which I've touched on a little bit. So the way we're going to mitigate that risk is we're going to do something called a guarded blower door test, which we're going to get into in a little bit, but not right now. So once that envelope is done, your service cavity can go in, and then your thermal clips can go in, and this is all independent of the interior work. So the thermally broken clips go in, insulation goes in. We're going to talk a little about Rockwell in a little bit. We're using it extensively on this building. Then the metal panels go in, and then your envelope is complete.
So the alternative is the panelized wall system that we used at Cornell Tech. And so, this is just showing how they erect. The panels are about 10 feet by 30 feet. So you get a stack joint, and then you get these vertical joints as well. And the benefit is that this is built in the shop. The parts that are the most difficult, taping around the windows, making sure you don't have inadvertent thermal bridges. That's all done under close supervision in a shop that's not beholden to the weather. But then when it comes time to hang it, then you're beholden to the wind. But what's a benefit about this is that once the superstructure is in, if you guys were around Roosevelt Island, it was like a big concrete skeleton, and then 4 weeks later, the building was clad. It went boom really fast. And it's partly what John was mentioning is that we needed to get people in working on the interior environment. So on the left, you have the Cornell Tech section, wall section. It's a prefabricated metal panel. And then on the right, we have the Sendero Verde. It's a masonry building. I'm just going to kind of walk back and forth a little bit, some comparisons between the two systems. You can see they both have high-performance triple glazing and a thermally broken aluminum frame. You can see that stacking joint right there. That's the weakest part of the system. That's where we have to field apply the insulation, and you'll see a little bit further on, that's where we have to wrap the air barrier around to make sure that it's continuous. Then on the left, it's rain screen metal cladding system, thermally broken clips. On the right here, it's jumbo Norman. These are those clips. We have galvanized brick ties. This is pointing at the wrong spot, but at the anchor here, we have an Armortherm thermal brake pad that creates a thermal break between the steel and the concrete edge of slab. We're using 6-inch structural studs here. We're also, in our building, we're using a steel stud backup wall. So that's another comparison between the Grand Concourse building and this. Amount of insulation is about the same. The reason why this has variation is that we actually had some depth in the wall. Those metal panels, had about 3 to 5 inches of play, so we had some depth to create some architectural articulation. On the brick, we're flat brick, everything's aligned, and so it's more consistent here. And both, and you'll see this in a lot of our projects, we're always employing the service cavity, and what that does is usually you have your air barrier right there, and this allows some protection. So like when you have users coming in to their building and they want to poster on their wall or want to hang a frame or something like that. I say posters, Cornell was a graduate student, so I'm thinking dorm style, but like if it's your residence, you want to hang a frame on the wall or something, you don't want to, by accident, puncture your very important air barrier. So everybody's using service cavity. You can put outlets in the walls that way without worrying about whether you're going to damage your factory-built panel. So this is showing where is our waterproofing and where is our air barrier. Very similar locations in both. We had a smart vapor barrier on Cornell Tech, and that allowed that during the wintertime it would keep the humidity in the building, but then in the summertime it would let that vapor get out of the building. We don't have that here. On the masonry here we have a vapor barrier here, and then a permeable waterproofing so that we can dry out this cavity.
So only one of our buildings has been poured in place. The others have either been block and plank or ICF and plank. Now, I'll talk more about ICF because, and so these are wall sections of the two buildings. The ICF system, and I'll get into a little more of this in a slide or two, is a much simpler way because inherent in the ICF, it's an insulated concrete form. It is you basically build up the blocks and pour concrete in. Is you have your insulation, your air vapor barrier, and the studs for both the interior and for the exterior for brick ties, all built into the system. So your detailing, and we'll talk more about the windows particularly, but as compared to the, is this working here? Here we go. This is block and plank where you put up the CMU, you put up the block, then you have to put the air vapor barrier on, then you put the insulation on, and then you put the brick on, and on the inside, we actually have more insulation, so we're putting, and then we have studs picking up the gypboard. So it has many more steps, and the problem with many more steps is there are many more chances to goof. The air vapor barrier, the ICF, you've got the ICF here, your bricks are on the outside, and your gypboard goes on the inside, and you're done. And the other advantage is, although there is a panelized system, but if you don't use the panelized system, it takes you longer to do a floor, but when that floor is done, it's much farther along. And we're going to talk more about this, but the air vapor barrier, just the detailing, and we'll also talk about the therm modeling. As you need to make this a really, really tight building. And so your air vapor barrier has to be there. Everything you do has to be thought out in terms of that. And as we'll talk more about, your contractor has to be into it too. All of our buildings are affordable housing buildings. So the other thing is that the people are getting these apartments by a lottery. They're not volunteering saying, I want a passive house. The early passive house, which were single family, the person building it was the owner who was going to live in it, and they were committed to passive house. Here you're getting people who aren't, but the same with the contractors. It's really important that they get trained. So here are pictures of our ICF beach. This is Beach Green Dune 1. And just to point out, because we were talking about brick ties, you see these pieces here. What we did for brick ties, and I want to show it on the next, but basically the ICFs get stacked up, the concrete gets poured in, you have to wait 2 days, the plank gets put on, and you start the whole thing again. But what we were able to do is you can see here, they're pieces of plywood. These are for our unitized ERV, and we'll talk more about that a little later. But you can, up here is a good example. So what we did was we cut out like a 4x4 hole. We mounted a piece of plywood with some reinforcing. When you pour this in, you then have this all set up for your angle, and you then ideally put a thermal break on the outside of that. But it worked pretty well because one of the issues we're getting into more and more is, first of all, your cavity is getting bigger, so you're needing to go to a bent plate instead of an angle, which is more expensive, or you're looking at these systems which have certain adjustability issues to mount to, in effect, push the angle outside of the insulation, which is clearly a better way to go. But this works out quite well.
All right, so talking about the envelope, and now we're going to talk about some windows. So this is a pretty key point. We're looking at about a 23% window-to-wall ratio. Now, to give you an example, in some of our condo projects, we're closer to 40, 45. And so there's a different expectation in a passive house building. You know, people are used to pre-war buildings and having mass and windows, and now we've gotten to this kind of floor-to-ceiling glass. So it's a little bit different in a passive house. So then, remember, I was talking about the articulations on the facade and why we had different window depths. You can kind of see the faceting on the metal panel to create these ribbons along the building. So talking about the windows, this is the Cornell detail, triple glazing. We're using a warm edge spacer. That's pretty key, and it's actually something we're starting to use a lot in our non-passive house buildings. This red guy right there, it's a thermal break for a structural support of the curtain of the metal panel wall. Now this was a design assist. We worked with Eastern Wall Systems. This was not invented prior to this job. They made it for us. It's enabling us to maintain continuity of our insulation by having that thermal break right there. In doing the windows, it's all about therm modeling. You'll see what happens when you start to concentrate a lot of metal in one spot, like that. Those therms start to pull in, and that's telling you where you need to put your air barrier to prevent moisture building up in your building. This is the Sendero Verde detail, very similar window, looks very similar. We have some pin applied insulation, and this is also thermally broken. Therm model, we got a little better this time. You can see that the lines are a little bit straighter through here, but I think that's kind of, that's part of the reason is the system that we have. When you have masonry system with the stud wall and our sheathing, we had a much more continuous, less bumpy exterior. Now, to do these windows, you have to put your facade through the ringer. This is a PMU. We're doing thermal model testing. These are little nodes measuring what is the temperature to verify what we are doing. And this actually, you can see a couple of these points right here. That's one of those vertical stacking joints. And that was like the least performing. So doing the PMU said, hey, we need more insulation here. And so we had that service cavity. We actually pumped some insulation into that spot just to make sure that we were meeting our comfort criteria on the inside of the apartments. Now we've been talking about air sealing. Let's get into some of the details. This is that same PMU. So we're, you're used to seeing this on a lot of projects. We do this on our passive house projects too. Making sure that we have a nice air-sealed condition. Now, this is what a panel looks like when it came to the site, and you'll notice right away that the air barrier is not continuous, right? We have these, you can see the insulation there, and then at each of these points is where you have your anchor on the slab edge. The windows came in pre-taped. and then they're lifted into place. And so this is what it looks like when it first gets installed on the floor. And you can see these flaps. You have these anchors supporting the mega panels. And these flaps were on the facade prior to the panel. So when the panel got there, we could finish the air barrier and then unwrap the panel at the top and bottom. And so this lower part of the air barrier was done on site. But as you can see, the amount of taping that you have to do to make sure that these windows work, we're very glad that we did that in the shop. Okay.
So this is our beach dune. One of the things I want to, a few things point out, we've basically used UPVC windows in all our, we did fiberglass in one in our passive house buildings. And the reason is basically cost. Now, these are European UPVC windows. They're not your grandfather's vinyl windows, as it were, that were really junky. These are very solid windows. They have a steel frame in them, and they work really well, both in terms of the thermodeling and not having cold surfaces. To get an aluminum window to do that, you can, but it requires more thermal breaks and it becomes a much more expensive window. So just pointing out here, this is actually a blower door test of the window setup, which you can see here. It's really important, as I mentioned before, on our two projects that passed the final blower door test, you don't want to get to the end of the job and not have tested everything, because it's hard. There are ways, if you fail a blower door test, to fix it, but they're time consuming and not easy. So we tested the window mock-up because that's really the critical spot, particularly with the ICF. But also we're now doing block and plank, and the contractor, some of the early air vapor barrier on the exterior of the CMU wasn't very thick, and they were being told, hey, you better fix this, we're not gonna pass. Whose is this? Okay. This is yours?
So I mentioned earlier the guarded blower door test. And I guess when I was describing the field-built system, I wasn't conveying to everyone my degree of concern about it. It's going to be a tense part of the job, but the way that we're going to, or the way that I've personally become comfortable with that, is that we're going to do this guarded blower door test. So at the bottom of the building, we're going to have a proof of concept. We're going to isolate a floor at the base of the building where we test the envelope. We're going to pressurize above and below, and then you test this floor, and you test the envelope performance of this floor. And what that allows you to do is find out where the flaws are, if there are flaws. And you work with the contractors that are installing those components and tell them, for the rest of this building, this is the way you have to do it. So you can test it here, you can make sure the concept works, and then you can do it throughout the rest of the building. In a 300,000 square foot building, if you've got a leaky building, to try to track down all those holes, so you want to get it done right the first time. So this is how we're going to do it on 425 Grand Concourse. We're going to isolate this floor with the pressurized above and below, and then using these fans, we're going to do smoke tests and really prove out the concept with the contractor. We have the same contractor that did the Cornell Tech building, so we feel pretty comfortable with this approach, but I'm going to be relieved when this part of the project is done. So this is how we're going to do it at 425 Grand Concourse. We're going to isolate certain parts of the building. We're going to be doing this when the hoist is still in place. So this is going to be the hoist unit. We're going to close this off. We're going to put up temporary barriers. This is going to be the finished, or not finished envelope, but this is going to be the windowed and the air barrier and the flashing details. We're going to isolate things like the stairs and the elevators and electrical panels, because they would give you a false reading because the rest of the building isn't sealed up that way. And this is what it'll look like in that temporary state. So we'll be sealing off electrical panels, these temporary barriers. Okay. Is this you or you?
This is
right.
Yeah, so talking about heating and cooling, this is Cornell. And the concept of the architecture actually followed the concept of passive house, and we basically have this well-insulated wrap around the building. And then at this one spot, the exterior envelope breaks. It's the lungs of the project. You can kind of see it in the thumbnail here. And at that spot is where we have these condensers. And so this is breathing in and out and supplying these console units. It's VRF, so it's refrigerant. And we have 2 loops. Cornell was great in its orientation, north and south. So we end up having 1 loop along the north that then fed 2 floors, and then 1 loop around the south that fed 2 floors. So like the north side obviously is going to be in heating longer than the south side. So you can have that level of control. And one of the things that when you see these perimeter loops, you think, well, how did you get past columns? And what we did is we actually, you can see here, we pulled all the columns back from the slab edge about 8 inches, and that allowed us this kind of raceway to run the refrigerant. It's a little tough when you have like hammerhead, shear wall conditions and things like that, but we did it. And so we have these 2 loops, south loop and a north loop. Here's that condenser porch. So we have this grill that became a primary part of the architectural expression. And so it's bringing in air here and then directing the air out. The reason why we have this like ductwork above the condensers, you really want to force the air out. Otherwise, you want the air to go out that way. You don't want it to kind of short circuit all the way up the building, because by the time you get to the condensers that are up here, they won't work. And so this is very important to have enough space in your condenser porch for the equipment to function. This is Sendero Verde. Now, the orientation is on the New York grid, which is not north and south. So north is up on the page, and so we ended up making 3 zones. We have this kind of eastern zone, a southwestern zone, and then this north zone here. And so like the loop here is now, instead of being 2 floors, it's 3. And you'll see in the masonry building, we decided we wanted to take the refrigerant loops inside. So it's an interior route. Only crosses the corridor a couple times. That's where you need to be 2-hour rated. And then we're using a different system. On Cornell, we're using perimeter consoles. Here, we're using these VRF closets, whereas the machine's in here. And then it's a larger machine that then sends the heating and cooling ducted throughout the units.
So one of the things that we've found with passive house is that the industry has a little bit of catch-up to do. The passive house loads are so much lower than a standard building that the equipment just isn't available out there for the actual loads. So a typical multifamily building has 500 to 700 square feet per ton of cooling load. We're finding it's about half of that for 425 Grand Concourse, and that's probably very similar for my colleagues here. Next.
So we've used 3 different heating and cooling systems in our passive house. The first 3 we're using VRF, and those were all done. Each apartment had its own unit. What we did is, and the problem is was implied, so you can put a unit on a wall, looks sort of like an air conditioner. The problem is now the smallest one is 4,500 BTUs, and in a bedroom you only need 2,000. And it gets complicated. So the other way to do it is to put a unit mounted in the ceiling and duct to the rooms. So we were putting a wall-mounted one in studios and the ducted ones in 1s, 2s, and 3s. However, the issue always becomes, we'll talk about ERVs, you've got ERV ductwork, you have then the VRF ductwork, and then you have the sprinkler pipes. And you don't want to raise your floor-to-floor height because that's going to cost money, et cetera. So VRFs are great. The other issue with VRFs is each unit has a filter. Filter needs to be cleaned every 6 months. That means that the super has to get into the apartment every 6 months. And when we talk about unitized ERVs, we have the same thing. The final issue with VRFs, landlord has to pay for heat. At least all of our projects have been affordable housing. Landlord doesn't want to pay for cooling. Tenant can pay for it or not. Well, with a VRF, you can put a BTU meter on them, So that's what we've done. But that costs money, and you have to hire a company to monitor it and so on. And then what happens if the tenant doesn't pay? It isn't like Con Ed where you can shut off the power. The landlord has to take the tenant to court. And now when you look at the costs and so on, that becomes a problem, because if the tenant doesn't pay, it probably isn't worth going to court. And so the landlord is sort of caught in there. So then on Beach Green Dune 2, which is out on the Rockaways, we're doing a ground source heat pump. The nice thing is we only had to go down 400 feet. I worked on a heat pump in Manhattan where they were going down 1,400 feet through schist, and that gets very expensive. But here it made sense, and so we're doing that now, and it's going to be really interesting because we've got phase 1, which are VRFs, and phase 2, which is ground source heat pump, and we're going to be able to compare them. Well, the different wall constructions and different ERVs, so there are a few different things to compare. Finally, so our client, Bronx Pro, we did this first building that we've just finished with them with VRFs. They said, I don't want to have to clean filters, and I don't want to have to deal with my tenants not paying the bills. And I don't want to have to pay for the BTU meters. So we've come up with this system, and we've done a mock-up, and we have a third model, which is basically we mount an air conditioner. Here's my window. Here's the air conditioner mounted in the window. I build behind it a second window. Doesn't need to be glass because you're never going to see it. So here that is. So we put an insulated panel. Here's the air conditioner. We've now tested this. The only problem is we tested it in an existing wall, so it was rough. So getting the seal around the edges was hard. But it models, it works. You can see the therm model here is actually quite nice. And then we're using a hydronic baseboard for heating. So the landlord pays for the heat. The tenant opens the window, plugs in the air conditioner, and pays for the cooling. There are no, I mean, yes, the air conditioner has a filter the tenant should clean, but we've gotten the super out of having to clean every unit every 6 months because we're also doing a centralized ERV. So we're now, our next 3 buildings with this client that are passive house will all be this system, and we'll see how it works, but from the testing, it should work fine.
Okay. So in New York City, we have a bit of a conundrum when it comes to energy recovery ventilation. One of the benefits of passive house is that you do get this high indoor air quality. And you're able to do that because you're doing energy recovery ventilation. You're bringing in outside air at the same time that you're exhausting air. But when you're doing that high air quality strategy, you are potentially throwing away a lot of energy. When you bring that air in and you condition it, and then you exhaust it, you don't want to just throw that energy away that you've invested in that air. So one of the fundamentals of passive house is to do energy recovery ventilation. So that outgoing air, the energy that you've invested in it, you want to recover that energy and transfer it into the incoming air. And this is done through a variety of systems. I'm not going to get into the technicalities of that. But so in New York City, we have hot, humid summers and frigid, cold winters. And that poses a challenge for which system do you want to use? Which approach to energy recovery ventilation do you want to do? Do you want to recover both the latent and the sensible heat, or just the sensible heat? And I'm talking about moisture. In the wintertime, when you recover that energy that's related to that vapor, that moisture that's in the air, you've got a potential problem of condensation within your building. So when you think about the summertime and all that humidity, you're working to get that humidity out of the air through the refrigeration cycle. You want to recover that energy. So in the summertime, the ERV makes a lot of sense. In the wintertime, when you've got that potential moisture risk, the HRV makes a lot of sense. So there are ways that you can, swap out the core to change an ERV into an HRV, but nobody's going to do that. So what we found in our projects is that ERVs is the most sensible choice for our climate, but you have to deal with the moisture risk. And there's ways that you can do that. On 425 Grand Concourse, we're doing this thing where we slow down the enthalpy wheel, in the wintertime when there's potential risk. So you're actually throwing away some of that recovered heat, but on balance, it's the right way to do it, or it's the strategy that allows us to not worry about that condensation on the cold surfaces at the envelope. So at 425 Grand Concourse, we looked at a couple different strategies for energy recovery ventilation. There is a system called semi-centralized, which is basically you have a unit that's on the floor, and you duct to all of your habitable spaces. Some of the challenges with this system is that you're basically sacrificing usable square footage for a mechanical unit. And the way we approached this project was we have an affordable housing crisis in the city. So we are trying to maximize every every square foot of floor area. Also, routing these ducts through the floor would increase our floor-to-floor height. These are large ducts to serve a large floor plate, so that would have caused our floor-to-floor heights to increase, and also loss of floors within the building and loss of units in the building. So we moved away from this strategy primarily because we wanted to maximize the number of units that we could achieve at the site. So another system, Mark has talked about this system a little bit already, is a unitized system, a unitized ventilation system. Now you can see in this particular solution, we had a lot of ductwork. A lot of ductwork that was expensive to build and would have resulted in a lot of coordination issues in the field and air barrier testing at the perimeter at every one of these perimeter openings for a 277 unit building. That's 544, if I can't do the math in my head, but it's a lot of openings to have to worry about. So we moved away from this system.
So I'm going to just talk about, so our first three buildings were the unitized system, and one of the ways we solve some of the issues that John's talking about is, here's our ERV, it's right in here next to the exterior wall. We exhaust high on one floor and low on the other floor. We still needed to go to the building department because the building department wants your supply and exhaust to be 10 feet apart. When you're doing a 9'4" floor to floor, that's hard without offsetting and so on. But all the manufacturers say you only need to be 5 feet apart. So we did this. We've done the determination now 3 times and gotten it all 3 times. And so this worked well. The other advantage from the owner's perspective is it's on the residence meter. It uses very little power. From my perspective, you're not putting ducts between apartments, so the air sealing of each apartment is easier. However, we have a big access door because you got to clean the filter every 6 months. And as I said, that's an issue. You do get into a fair amount of ductwork, but by pulling it out here, our supply ducts come from the kitchen and bathroom, and then the return ducts go to each of the bedrooms and living room. And it makes it easier because it's a shorter run. But our clients did not like the idea of having to get into the apartment every 6 months to clean the filter. That was the big issue. So on Beach Green Dune 2, which is in construction, and the other ones, we're going to a centralized ERV. It's on the roof. We've zoned the building into sort of 3 wings where we have here's our coordination diagram of how we worked out the supply and return and coordinating with the sprinkler lines and so on. And it all seems to work. So we're doing this. Now this we needed a determination on too. Because at the top, building department, except for a unitized in an apartment, does not allow you to combine kitchen and bathroom exhaust. But we want to minimize the number of holes through the roof, the number of ERVs. So what we did is we got permission above the top units, and we had to add height in the top floor. We connected the exhaust and ran through the ERV as one, and then the supply comes down as one. And DOB has let us do that now. We've gotten it at least twice, so I think they're fairly comfortable with it.
Okay, so this is 425 Grand Concourse again. So this is where we ended up. We ended up with a centralized ERV system. You can see a lot less ductwork if you remember back a few slides ago, all that ductwork that was on the floor plan. So a lot less ductwork. But this isn't to say that this is the only solution. Mark has shown you another valid solution. Ryan's shown you different solutions. I think one of the takeaways that we'd like you all to have tonight is that there is no one solution for Passive House. That depending on the site constraints, the owner's operational issues, there's a variety of ways to approach these different systems and these different Passive House requirements. So on 425 Grand Concourse, we split the building up into a high house and a low house. So we have our high ductwork coming up, and that CCD1, that determination that Mark talked about, we have the same thing. And it occurs right here where the exhaust connects right here, and then the supply comes down. So the Department of Buildings has granted us the determination on this project as well. So we have the high house, the low house. This is a 26-story building, so we've utilized it effectively, a very similar system on our other lower scale buildings. You can see how the ductwork works in this building as well. There's something called a dormer. Those of you that are familiar with New York City zoning, we have a dormer on this building, and we're doing this kind of acrobatics with the ductwork to make this work, but it's a system that we feel will work.
Right. We also got that CCD1. They're handing them out. Trick or treat. All right, so Cornell, we use ERVs on the roof. It's 26 stories tall. And so the path here was that, these are the studios. We're bringing fresh air to every apartment with a riser, and then we're exhausting each apartment, each kitchen, each bathroom with a vertical riser. It works, but it's a lot of duct openings. And so this is our strategy. We're kind of lessons learned. Maybe don't turn your slab into Swiss cheese. Your structural engineer will appreciate that. And so this is our strategy on Sendero Verde, where we have one large central supply air and then horizontally distributing that to the apartments. And so above we have a drop ceiling in the corridor, and then we have this horizontal distribution that is supplying to each unit. And then we have shared, this is shared toilet exhaust, this is a shared kitchen exhaust going back up through. So it's similar, but it cuts down by about half the number of penetrations. So odds and ends. We've talked about it a couple times. I know that the Grand Concourse buildings using Monadnock, they drank the Kool-Aid, all right? They are with us. And so it's about making sure your CM knows, making sure the sub knows, hey, this is an airtight building. So like on the trailers, this little sign was there. And every floor, when you get off the lift, you saw this sign. You don't want to you want everyone to know, hey, don't lean a ladder against your air barrier. The service cavity isn't up. Don't go, if you have a bunch of belts and hammers and things, don't go leaning against the air barrier. You have to know about this, because if you may not know that you put a hole there, but when you go through and do your guarded blower door tests, people are going to find it, and that's work that somebody else has to come back and tape. So it's important to maintain quality control that everyone buys in early on in the process.
So on Beach Green Dune 1, we had both photovoltaic and cogen. And I'll talk a little more about the cogen later, about the easy ways of not having it work right. But the concept was we were going to produce energy. This is also out in the Rockaways, gets flooded often, could have power out, so having some power. But the other thing I just want to talk about for a second is the net zero and how it is sort of something in New York you can't basically do, but we shouldn't worry about it. So anyway, in Beach Green Dune 2, we've got more photovoltaic everywhere, in the parking lots, on the roof, and so on. We may be doing 80%, and this is a 7-story building, 80% of the energy generation on average is being done. We can't get to net zero. However, there are a number of schools in Kentucky, I know about them because they used ICFs, are really good, passive house. They put the whole roof as PV. It's a net zero building. But if you look at the carbon footprint per capita That school, everyone drives to. Our buildings in New York, 80% of people use mass transit. And so our carbon footprint is much less. So it's really good to put all of this stuff in and minimize the carbon footprint and do on-site generation. But we should understand that net zero in New York City, unless you're doing a single-family house, is probably something you're not going to get to. Now, doing passive house gets you much, much closer to it, but it's just not something. But and the cogen is burning gas, so it is creating a carbon footprint, but it is about half of what just doing hot water would be, because the byproduct of generating electricity is the hot water for heating, so we're not wasting the energy.
So when you spend all this energy and time coordinating a passive house building to get savings on your HVAC system and the amount of air that you have to condition, you'll notice what happens to this big old pie of what is an energy use in a passive house building. When your heating energy, cooling energy is 11%, what are your big demands? It's domestic hot water, it's plug loads, it's lighting. So identifying, we're just talking about net zero, it's identifying what are those next big ticket items that you can target and to reduce. So like, of this 34%, like 3/4 of that is just our refrigerators on our job. So like choosing smaller refrigerators may be a choice that we want to do, and it may have significant repercussions on your overall energy use of the building. So, but talking about domestic hot water, we want to make sure that the hot water is being used appropriately. So, if you have commercial cooking, you're not going to make sure that it's outside of the passive house envelope. It's very, very hard to deal with that. We don't have swimming pools in our passive house projects. You just can't accommodate that amount of pumping, that amount of conditioning of the domestic hot water.
I just want to add something. Water bills are going up fairly fast.
Right.
And so not only is it a higher energy consumption, it becomes a bigger expense for the client. And so the next thing, and we're starting to do with this, are gray water systems and other ways to reduce the water consumption, because even though there's a cost in that, long term there should be a savings over the client. It doesn't really affect passive house directly because it isn't an energy issue.
So a couple lessons learned from Cornell. We had that condenser porch, and we were very proud of ourselves as fancy architects. We wanted the best door you can add. It's not even a door with glass. It's in a back of house mechanical space. So we got this nice refrigerator door that you would see in like a deli. It's well insulated. We were able to air seal it great, but we found out that it's actually overkill. We didn't need to do this much. And the building is large enough. Remember that surface to volume ratio? The building is large enough that instead of doing an R value of 28, we were able, on Sendero Verde, we're using this Checo door. It's a mercury thermal break, hollow metal door. Everybody can use these on all your projects. And it's 2.78 R value, and it meets all our criteria. It's better than your average door, but it's not, this is on steroids, guys. I kind of mentioned this earlier. There's materials that we're using on our passive house projects. We're like, hey, we can use this in all our projects. So it's these thermal clips on rain screen, insulated CMU block. We have these different types of gaskets. I mentioned the warm edge IGU glass spacers. We're using this on a lot of our projects now, whether they're passive house or not. We can kind of spread our knowledge, spread the wealth, and get in our underperforming buildings to start performing better. We use a bunch of isolators on our project. We had the Shook steel-to-steel isolator we have this large canopy on Cornell, and we also used the Shook concrete for that condenser porch, which is outside the thermal boundary. This General Plastics, my gosh, guys, invest in this company. We use this stuff all over the place. Dunnage, when you're trying to separate where your concrete slab is from where your dunnage, and this is high density foam, basically. You could support like 7 dump trucks on this. It's way overkill just to support an ERV, but that's what we're doing. And it gives us that thermal break that we need. different tapes, different types of vapor retarders that we're finding uses for on our typical projects. We were talking about this before, like this is a 1-ton evaporator, and we really only needed that much. So these companies are starting to see, hey, New York, they're doing passive house there, and we need to start making our products that fit the actual size you need. So like inside, if you open up this machine, it's only like half filled. They don't have the cabinet the right size. It's ridiculous. And so this is something that we're seeing VRF manufacturers start to finally encounter.
And I'd just add with that, one of the biggest issues in doing passive house is things like ERVs or windows that come from Europe. This is becoming less of an issue. They don't have their UL testing. The windows don't have all of, we often are next to train tracks and have sound requirements, and they haven't done all the sound testing. Or they've done it in Europe, but that isn't technically something we can use here. That is, over time, becoming less of an issue. So Beach Green Dune was finished a year ago. We've gone through 1 whole year. And so for heating, it was costing $98 a unit with both the cogen and PV, but it should be lower. So I'm gonna we're starting to learn, you do a passive house building, it then needs to be operated somewhat differently. Your staff needs to be educated. Your maintenance people do. So this was the modeling for passive house, and you can see my space heating and cooling down here is very little like the other one, and the hot water is the biggest thing, and then large appliances. And we were going to generate a quarter to a third of the power. Here's what a typical code-complying building would need. So we're down at about a third of the power energy that you'd use in a code-complying building. So the basic news is it works. So we're 11% under the model with actual. And one of the things, and my client, Steve Bluestone, has like 30 slides on trying to do this analysis, ending up with a beer and an aspirin, because it's like the Department of Finance and the building is 20,000 square feet larger than it was. And you start to go through all the data and how do you get it and normalize it. But actually this house, PHIUS was our certifier on it since it was the first really large passive house that had been done under the program. And they spent a lot of time doing this analysis. So why are we under? And there are 2 reasons I can give you. The first one is code requires you heat to 68 degrees. Our clients decided to be generous. They were going to heat to 72 so people wouldn't complain that it was cold. They forgot to set the thermostats. So here are some of the 101 thermostats, and you see we've got lots of them at 76, 77. Obviously, you're going to need more energy for that. They decided when they figured this out that they better wait to the end of the heating season. So now it should be limited to 72, and this year we should see some improvement. The other thing, here's our lovely cogen system. It's cranking away, making hot water, making electricity. Someone turned the valve off. So the hot water isn't going into the system, and we're losing the benefits of the cogen. And it was 3 months till they figured this out. So, you know, there are going to be teething pains in any building, and with a passive house building that has somewhat more complicated systems, you'd expect some more teething pains, and there were.
Yeah, so we've been talking about the kind of technical aspects of passive house, but it's also important to kind of take a step back sometimes and remember, who is this about? It's about the people who are going to live in these spaces, and it's about this, a major part, if you remember back to the very early slides that Andreas showed us, it's about thermal comfort in the apartments, in the space that people are using. And so I like, this is a studio, this is like, it's a school, so obviously there are a lot of hangout spaces. But I just like to show this slide. There's a view here. It's a little washed out, but that's the Queensboro Bridge. You know, one of the benefits of having this bunch of insulation and air sealed and thermally broken is that when you're in that space, you don't hear the traffic. It's quiet. There's an acoustic quality to a passive house space. The air is healthier. You know, it's not just about saving the environment. It's about making a healthy place for people to live too. And so I just wanted to, here towards the end here, just kind of bring us back home to this idea.
And then these are some of our images, although I have to say, the one on the left, our marketing person put in, it's not a passive house project, but the other two are. And actually, Beach Green Dune 1, you can see something, we're in a 5-foot flood zone. So, I mean, one of the nice things about passive house, no power, it will never get as cold, it will never get as warm, it is passively survivable. But in this case, this one also needed to be, if it gets flooded, when the water goes out, I can point out the flood vents, it will all be fine.
All right, questions?
Thank you so much. I am continually sort of amazed at the willingness and eagerness of the professionals in this community to share lessons. I think it happens so often we take it a little bit for granted, but this does not happen in other industries. You'd never get Bic and Schick and Gillette up here talking to you about how they make their razors differently, and oh wow, I learned something about your production process. Let's do that next time. We get sort of used to it here, but I think it's really important, and honestly, not to get too grand, but it's part of how we're going to save the world. So this has been fantastic. We're trying to kind of advance that sharing a little bit. Tonight, we're part of a United Nations network. It's sort of a mouthful. It's called the International Centers of Excellence on High Performance Buildings. Everything that comes out of there is a mouthful. But it's a great initiative that we're part of, and we've partnered with some other progressive cities that have similar centers that are either online or coming online. One of them is in Vancouver. They have a similar center that they're developing called the Zero Energy Building Exchange. Sounds kind of similar. And there's a group of them watching right now. We are beta testing the live stream tonight, which is really, really exciting. So I'm glad you all behaved yourselves. And we may even have times to take some questions if they send any in virtually during this portion of the evening. Sean Torbert, newly ensconced as public affairs manager at Rockwool, is gonna ask the panel some questions and then kind of run the Q&A from the audience as well. Sean?
Okay, thanks. I think, is my microphone working? Yeah. Okay. Thanks. So thanks, Yatza, and thank you, Mark and John and Ryan and New York Passive House, Andreas, everyone for letting me participate in this. So. I see some familiar faces. So I'm Sean Torbert from Rockwool. I used to be the New York City architectural specifications manager, so I've been fortunate to get to work on a lot of these passive house projects, and it's nice to see them actually being built and coming to fruition. But real quick, I want to embarrass my replacement, Todd Kimmel. Where is he? Did he run out? There he is in the back. So yeah, Todd Kimmel is the new New York City Architectural Specifications Manager. He is a certified passive house consultant and designer and based in Brooklyn. So if you have any technical questions on anything you've seen here, ask him, not me. So again, thank you. I'm going to start off, I guess, it's just the first easy question. I just kind of want to lob a softball to you guys. And why passive house? Why did you decide to do passive house? Is this something that your firms decided to do the right thing? Was it something that consumers were demanding, or?
I'll start, which is a two-part answer. We founded our firm almost 30 years ago with a goal to try and create sustainable buildings in the largest sense of the word. So we've always been interested in energy efficiency, sustainable. But with that said, we have had our first passive house was with Bluestone Organization, and Steve Bluestone had been working to do this for about 10 years. We'd done some other buildings with him, and he wanted to do it. We wanted to do it, and so we did the first one. Once you do one, it's easier to convince a client to do the next one because you've done it before. And I think now that we're starting to have data, and credit to the city that they've been willing to fund the slight added cost to do passive house.
Yep. I also, I come at this from a personal perspective. You know, I yell at my kids to turn off the lights when they leave the room. I think as architects, we really are, we should feel an obligation to be leaders in the industry. And if we aren't pushing the envelope, and I don't mean to make a pun, but if we aren't advocating for lower energy buildings, then nobody else is. I had an epiphany a couple months ago after starting to work on my first passive house project, and that was that once you start thinking about passive, it's really hard to go back. Once you start thinking about thermal bridge-free design, and once you start thinking about air barrier continuity, it's really hard to go back. I'm sure both of you may have had those similar moments. So I think, you know, we really should be doing this.
Cornell Tech was a competition. We were interested in passive house as an office, and then we entered into the competition with a, I think, very forward-thinking developer, Hudson. David Kramer there, he's been to Vienna and been into all these passive houses, and he saw that there's a connection here to high-rise in New York, and he really wanted to do it. And so we partnered up with them on the competition with Cornell, and basically we did a version of the building which was, you know, LEED silver and good, and then we said, but you can do this, passive house. And we kind of described what it was, and we went, you know, we won the competition. It still hadn't been decided yet. Everyone's still kind of open to it. And we had a bunch of meetings, really kind of going back and forth, and eventually Cornell was on board too. It was that campus. You look at the net zero of the Morphosis project, the amount of PV, that's these lily pads that are on that project. Every building there has a kind of a green initiative that it's following, and so we hadn't yet. You had to be LEED silver, but you know, we all know how in an urban environment how easy that is nowadays. So it was developer driven, and so that was pretty impressive to me. And now the city is seeing what's happening. The Sendero Verde project, that was an RFP, and so it's really amazing, like the kind of the momentum that is really starting to get going here in New York.
Great. Yeah, and are you finding that you are, you know, all of you being pioneers in the passive house sector, are you finding customers actively seeking you out, or is it something that you've kind of put into your sales pitch to potential customers, and how are you doing that?
I think, you know, in New York City we have, there's not the easy sites to be developed that are left. There's things that are, you know, either they've got a lot of rock, or they've got complex geometry, or they're right next to an elevated train. So when you think about the environmental conditions that come with something like a noise-producing environmental condition, like an elevated train, or the major Deegan, or other like major thoroughfare, and you've got a noise condition that is that's going to be just part of the development, and you're investing in that envelope anyway to not have through-wall air conditioners, or not have PTACs, to have high-performance windows. Passive house is kind of like it's a natural question to ask the developer. Just, you know, we're halfway there, let's make a little bit more of an investment and then really reap the benefits. So it's part of a marketing pitch. It's part of, you know, Mark and I pursue a lot of RFPs through the city. I think HPD has shown real leadership there, so it's one of the things that they kind of want to see as almost a threshold issue. So I think it's a variety of things. It's marketing, it's, you know, personal. I think all of us have this kind of personal vested interest in it. So
yeah, a lot of tires are getting kicked. You mentioned before, like how we're willing to share information within our industry, and I think that our attitude is, yeah, it's about protecting Mother Earth, protecting our house. You know, and so it's about getting, you know, we don't really care who sees these details, because we want everybody to be heading in this direction.
Sort of the Linux version versus Microsoft.
Right.
I just added, taking on with what John said, the last two RFPs we've run, both been passive house, one with NYC and one with HPD. And I don't think that's a prerequisite, but you're always looking for a hook when you do an RFP. And I know we and a number of other firms are doing that or suggesting it to the client as a matter of course.
So moving on to another question I have here. The most recent IPCC report claims that we have about 12 years to cut carbon pollution by 45% to mitigate catastrophic effects of climate change on humans. What is the largest challenge, in your guys' opinion, to rapidly implementing Passive House on all buildings in New York City, both existing and new, and then rolling that out to all cities in the US?
You got that.
I'll start on that, because we've been looking at this. The problem are existing buildings. New buildings are easy. We're all doing Passive House. Existing buildings with tenants in place in New York City, if you have a tower in the park, it's easy. We've come up with a system to overclad with panels and run everything outside, so the tenants would not be that affected. But most buildings are lot line buildings, have party walls, et cetera, and are going to be really hard. Then also what is about 20% of the buildings in the city are landmarks. Can you see proposing overcladding to the Landmarks Commission? So that is the real issue, and I wish I had a better answer of how to deal with it, because we've got to figure that out.
Basically, we're not going to meet those targets. We're not going to do it. I thought you were going to talk about the learning curve that we all have about getting up to speed on Passive House.
What's interesting, okay, I've gotten cued to it. I did a paper about a year and a half ago, a short paper at the Salins Institute, where they said, how quickly could we adopt Passive House? And what we found is Brussels did this, and they did it over 10 years, and they started by doing two things. One is all the public buildings were Passive House, and there were economic incentives. The economic incentives dropped down, the energy code went up, and they now do all Passive House. I think New York is starting to do that. I am very worried that the stretch code may be pushing it too fast, even though I totally believe it, and that we're going to have not enough Passive House trained people, enough people who know all the stuff we do, and then enough contractors who know how to do it.
It just takes one project to screw it all up for everybody. If one team goes about this and does it like in a half-hearted way, they don't have the good contractor, they don't have a good team, and Passive House gets this kind of like I don't know, bad mark on it. It makes it bad for all of us. So that's, I think, one of the reasons why we're willing to share so much information with our industry and our community.
I kind of take the question a different way, and we do a lot of non-Passive House projects too, and it's about everybody learning from, even if we're making large-scale movements here, there's still small things that everybody can do as well. And then, I don't know, like taking it even one more step farther back, I think, as people, we have to change our, expectations. Like, we can't expect to have floor-to-ceiling glass in every building. Like, we have to start, changing what, there has to be some sort of social consciousness, like if I go to my friend's house and he just bought a new construction that's floor-to-ceiling glass, I should frown and make him really feel, right? He should feel that social cost, and we're not 12 years, man, that's generational. I mean, it's going to take a lot of time for people to start to feel that way. We're not there yet.
So as a sort of follow-up to that, because it got me thinking, in talking about labor, right, which is an issue, especially in the construction industry. One, training, which, again, plugging the upcoming NAPHN training on November 12th. I believe is that the tradesperson training, if anybody's interested? Or designer training, and I believe there is a tradesperson training coming up as well. So one, obviously training, but also the labor shortage due to the sort of anti-immigrant rhetoric we're experiencing, as well as the aging skilled labor population in the U.S. Is there an opportunity to perhaps look at look more towards panelized, unitized, or modular systems as a quicker and more efficient way to implement passive house. I know, Retrofit New York is looking at that for similar strategy for all affordable housing in New York State. But obviously there's different opinions on this. There's different special interests involved. But I'd be curious to hear your thoughts on modular versus traditional built and the labor shortage.
Well, modular certainly seems like a way to achieve passive house. And I think, like on Cornell Tech, you saw some of the benefits.
Right.
Of that. You had high quality control on the panels. But in a place like New York City, where every site is different, the zoning is so constrained, I don't see modular as a kind of a slam dunk in the city. Labor shortage is it's another big issue. One of the things that Monadnock did on your project, and I've learned a lot from his project by using the same contractor. One of the things that they did was they deputized every one of the contractors, every one of the tradespersons that was on the site to be eyes and ears. So instead of having like one person that was the air barrier person, everybody was an air barrier person. So, and they got people coming into the trailer saying, hey, on the 15th floor, I saw a tear, and so they were able to go address it right away before you got to the guarded blower door test or before you got to the end of the job. So I think that's one way to address kind of the skilled trades issue, is make everyone a partner in this. And the signs is one technique, the signs on every floor, that's one technique. So I think there are ways that you can address passive house even with the skilled trade shortage.
I would add two things. We're doing our first panelized construction building, actually a project we did with Monadnock that's passive house. It was originally going to be panelized construction, and then we got the cost of the panels. And in a non-union, non-prevailing wage job, it was much cheaper to build it on site. Our panel job is a prevailing wage job. We're building it off site. The problem with modular is you can put up 8, 10 modules a day, but unless you've got a big parking lot next to the site to store the modules, you can only bring in 2 modules a day. And then there are issues as a modular has a higher floor-to-floor height and some other things, and also because each wall, you're building these boxes, every room's wall is 8 or 10 inches thick instead of 3 or 4 inches. So there are some downsides, but I think the biggest one is, well, the second biggest one is there are not many modular companies who make fireproof modular construction near New York City, so you don't get the competition. But the biggest one is, where do you store the modules, because you can't bring them into the city during the day.
Okay. Now, this next question is a tough one. And I know it can be a sort of political hot potato. But in terms of fire safety, there's been a lot of concern about multi-unit residential high-rise construction since the Grenfell fire about a year ago in London, which tragically killed, I believe, 72 people. So in response to that and the public outcry, the UK has banned combustible construction or combustible materials above, I believe it's 18 meters, which is about 59 feet. As we are pursuing more and more robust building envelopes, more highly insulated building envelopes that could potentially have more fuel in a fire situation, what can we do as a industry and you as architects to help prevent any public health and safety risks associated with fire in high-performance building moving forward, so we don't hopefully have to wait until 72 people die to change our codes?
Well, I think it's a different system that happened in the UK. Like that system that they had on that building is not allowed in New York or US. So it's a little bit apples and oranges. Mm-hmm. It is something that we're all concerned about, and it's weird that I'm answering this one first. I'm the youngest one on the panel. But we've talked about this. It's not just, we're looking at EFIS systems that are using mineral wool backing instead of XPS or EPS. It's not just about the fire safety that you get. There's global warming, blowing agents, and other embodied energy that's involved in using foam as a primary building insulation. So I think it's pretty cohesive how we're kind of attacking this problem. But that product, from my understanding, wasn't allowed in the United States for a reason. And so we're fully encapsulating our EFIS systems, our metal panel systems, and that system was like balloon framing. So it's not exactly apples to apples.
Yep. I thought you were going to ask about tariffs or something like that.
Do you want to?
You can go ahead.
I would add, there are a few things. As Ryan said, what was used in Grenfell isn't used here, isn't permitted here. I'm not saying what we have, I think about this a lot. So Grenfell did not have sprinklers, had one means of egress. The fire stopping in the units was substandard. So everything that could go wrong went wrong. That doesn't mean that won't happen here. I know the fire department is particularly worried about rehabs, but the issue we have here is space is very valuable. And so, they're going to need to be trade-offs, and hopefully everyone is conscious of this. And what is it, NFPA 285 has requirements that as everyone gets to know it better, or hopefully all following. That may not be a perfect answer to the question, but hopefully nothing like that happens here for a combination of reasons.
I think also, we touched on this a little bit in the presentation, but multifamily passive house, when you get right down to it, the envelope insulation values that you need to achieve your targets are not that much higher than a standard code building. So you're not talking about, 1.5 feet of insulation. You're talking about 5 inches, 6 inches. It does mean that you're beyond an XPS or an EPS insulation that would be allowed, or that I think any of us would be comfortable with. So you are talking about a different material, a different sort of insulation material. So it's a concern. It's something that I think we're all aware of and addressing.
Thank you. Okay, so for the people in Vancouver, I'm going to take just a quick look at if there's any remote questions here. Okay, I'm going to take this first one here for you guys. How does Passive House perform over time with regards to air tightness, wear and tear of envelope, and potential increase in internal gains and climate change? So it sounds like really it's a question about durability, longevity, and resilience of Passive House.
Ask us in 10 years.
I do think there's about 20 plus years of data, though, from Europe that we could potentially utilize.
The climate's very different there, but it's actually an interesting question about climate change. I mean, how much is our climate going to change, and how do you project a building's performance forward? Do you have to anticipate a higher cooling load on the building? I'd have to say I haven't thought about that. I don't know how significantly it's going to change over the course of a building's life cycle, but.
Okay. Here's a good question. Any unresolved issues or questions in high-rise Passive House that need more research to find effective solutions?
Dude, I want a storefront terrace door that's ADA accessible. This is one of the hardest things to find. We're constantly making complicated details to solve this problem. A lot of times you have a terrace or you need an in-swinging door. It's up at 26th floor, 36th floor. Got a lot of wind-driven rain. That's one product that we're not quite there yet. On Cornell, we had to use what you would find in a single-family residence. And so it's a nice window door, with multi-lock, but it couldn't handle commercial hardware. The sill wasn't ADA. We had to feather up the terrace pavers to make a nice smooth transition. So the industry isn't there yet. That's the thing that I really want.
I think the same thing goes for mechanical equipment. There's only a few manufacturers out there that really supply ERVs. I think you've had on your project equipment that hasn't been UL listed.
We had to change in construction because of that.
Yeah. So I think the industry, there's an opportunity here for other manufacturers to really kind of catch up with what I think is going to be a growing demand. At least I hope is a growing demand.
At the same time, in the 3 years we've been doing UPVC windows, when we started, there were 2 companies from Europe importing. There are now companies fabricating here. There's starting to be companies that make here. And so that I think as people realize the demand and that there are products out there that maybe they can compete with, you'll see more products.
We hope to get our 425 Grand Concourse windows from Yonkers. So
Nice.
pretty local.
Okay, I guess we'll open it up to some questions here. So I guess whoever has the microphone first, yeah.
So what have been your experiences working with building enclosure contractors, more specifically the panel and curtain wall guys? I mean, are there enough out there to actually bid a project? And the ones that are interested, how quick are they to catch on, or is there a lot of friction?
I mean, bidding a project is, I'm speaking of Cornell experience right now as our panel assist. The panels that we used, it was a design assist, so it wasn't a traditional bid like you would think. And we looked at a gasket system, which in New York City it's Island, and then we looked at a wet system, which was Eastern, and both had positives and negatives, and that we chose Eastern. They were great to work with, and they brought a lot to the table. There's a lot of experience and expertise that they had to help solve, when you're building, the world's tallest passive house, you're encountering things that you haven't encountered before, and they helped us through a lot of that. So it was more of a, I don't say design build, but design assist type process.
Yeah, and I think maybe the question behind your question, there's not a lot of contractors out there that are doing this. So if you go that route, you better know that you're going to have that sort of limitation on your project.
Mm-hmm. Okay, thank you.
Hi, so there's been a little bit of data coming out from AI 2030 about the life cycle analysis of new construction and how a lot of the global warming impact is upfront in the first, of course, with the embodied energy of all the materials that we're using. So are you guys considering or thinking about doing life cycle analysis of your high-performing buildings?
Want to try that one?
We haven't yet. I mean, from what I've seen, about 12% of the energy is used to build a building, 12 to 13%. Another 5% is used to demolish it, and all the in-between, so that cutting the in-between helps. The next step is to try and reduce the first cost, the energy cost. But
we've been looking at those type of things, nothing formal yet. I mean, it's a lot of, at happy hours within the office, like a bunch of people talking around and waxing poetic about what would a CLT high-rise in New York look like. And so we're not down to doing that high-level work yet, but I think it's a conversation a lot of architects are having, and we're close to doing that. On Cornell, it was nice that it was a developer partnership with an institution, and so they had a different life cycle in mind when they were planning the project. And so we did have some conversations with the ownership group about material choices and things like that, which I thought was very helpful to the project. But I would say that it wasn't a primary focus in the process.
How did you deal with the elevator shafts in the passive house and garbage chutes, if you have any?
So we probably have similar responses to this. The garbage chutes get special air sealing around them. I believe we're even doing like special gasketed doors at the entry into the chute. We looked at doing special gasketed doors that get you into that refuse room, but we're using that refuse room exhaust as part of our balancing of the corridor ventilation, so we couldn't seal off that area. So I'm sure you've got...
Yeah, it's very similar. It's a chimney in the building, and then it goes all the way down to the trash room. You know, in Cornell, we added some additional insulation at the top floors, at the underside of slab, and then at the slab, we're taping that joint between the CMU, but the CMU is getting painted, which on an interior environment, 2 layers of latex paint, it works as an air barrier. So like the air boundary is around the chute, and we're insulating the top almost like a little turtleneck up there, just to try and keep some of the ambient temperature higher, but it is open, and the elevator shafts as well. And in a single-family home, having something that large open in your project, it would be a complete no-go. You wouldn't pass your passive house. But when you're talking about a 352-unit building, 270,000 square feet, when you transfer we're talking about maybe 6 square feet, 8 square feet of opening across that entire area. I mean, we could have probably passed our blower door test with like a complete door open, you know. And so like the trash chute and the elevator shafts, their vents being open wasn't a killer on a high-rise multifamily project.
Just start talking.
For the folks in Vancouver.
So for the buildings that are occupied, are you finding that, how are you finding the number of days that you actually need to heat? Is there any data in terms of who's actually heating their spaces versus not?
We don't have that. I at least don't have that data.
Have you seen the hairdryer image? That you can heat an apartment with a hairdryer? I mean, that's our expectation. That's what we hope that the
single-family houses, we're finding that in the single-family houses, we're finding that they're not heating. They're heating 3 days, maybe 2 weeks tops. So I'm assuming in the denser buildings,
what we're actually finding is these, at least on our projects, that the buildings in New York City, buildings are heating load dominated buildings. In passive house buildings, it's completely different. It's a cooling dominated load building. So you're going to be cooling a lot more over the course of the year. So.
You'll have to excuse my innocence and my selfishness. I work for a supplier of PHIUS stucco. New to the industry, I tell you what, trying to get in to see your gentlemen or people that work with our products has been difficult. As a manufacturer, my question is, how do we come more of an integral part together? Because it sounds like some of the things that we make would be beneficial, but some of the things that you need also would be beneficial to us to know how to stay ahead of our industry.
Would you be willing to do therm modeling?
If I knew what that was, I guess the answer would be yes.
Okay. Well, I've given you some homework.
Okay.
Well, let me answer this a few ways. We do use PHIUS, so it isn't as though we're not considering the product. It is useful to contact people. It is also good to go to events like this and ask people, what do you need, or I can provide that, or so on, because we're constantly learning, but I'm trying to think of exactly how to say it. We're bombarded every day, so I'm not sure I always do a totally rational thing of reviewing everything I get fully when I get 300 or 400 emails a day, but I think it's a combination. And if the other thing I'd say is, I don't know if you know about NYC as well as the passive house. There are a number of shows a year. In NYC, there are about 50 different suppliers, and same with passive house, who are trying to sell you on very high performance energy systems, and the people who go there are looking for that. And I think that is a partial way to get known too. And then the other thing is just knocking on doors till people answer.
I would also say that there's this kind of conundrum in a way where, we need cutting edge material sometimes, but there's also when you're talking about material length and how long do we want these buildings to last, like we're not going to spec something in our exterior wall if it doesn't have a track record. So like that, you're up against this kind of, I want cutting edge things, new things to the market, but you also want something that is reliable, and sometimes material, different companies don't have that yet in the New York market on a high-rise building in East Harlem. Like they don't have all the check marks that we're looking for. So in that case, then we go to companies that, like for instance, Shook Isolator or something like that, where maybe they don't have the longest track record here in New York City, but they have a tremendous track record in Europe. That's like, I can send my exterior wall consultant to projects that have been around for 50 years with these products in them, and they can say, yes, this is work. We can, comfortably recommend the usage to our clients.
I think we have time for one more question.
Okay. Going back a little bit to what was discussed before, it looks like the energy codes are getting closer and closer to passive house, but it's a very slow process. Maybe it's a suggestion rather than a question, a way to educate the code officials to understand it better, and things like habit determination or combining exhaust, that should be an easy thing to get approved.
So that is now easy. I think in 2014 code it's allowed. So like that was a problem that we were coming up against in the 2008 code that it was resolved in 2014. It isn't?
Nah.
Okay.
Actually, in this room a couple months ago, there was a representative from DOB, and I said the exact same thing to her. They're working on it. It's slow, but they're working on making that determination.
And I would give DOB a lot of credit when you come in and you say, I'm doing passive house and I want to do this, and the code doesn't let me do it, but here's all the backup of why it's reasonable to do it. They've been saying yes. I mean, determinations are a pain in the butt, but if they get enough determinations, hopefully they'll change the code. I think for the unitized ERV, they're going to change, I'm involved in the next code update, they're going to change that so that they won't require the 10 feet with certain documentation. So you'll just have to provide it to the examiner instead of doing a determination. But it's all part of the process, and I think they've actually been quite receptive.
Yes.
Okay, well, thank you, everyone. Thanks again, Mark, John, and Ryan. New York Passive House and Building Energy Exchange.
Thanks, guys.
We're done?
Good.
Awesome, guys. That was
great. Thank you.
Fantastic, yeah.
Thanks, Andreas.
That's fantastic. Great. The format.
You guys.
Section by section was great. Thank you.
Thanks.
Appreciate it. Great. Thank you.
Thank you so much. Great discussion.
Nice Rockwell question in there.
Yeah, well,
We should add to it.
hey, that's my job, so I know it's a little pointed.